Hello students, today we are going to revise chapter number 8, part A, that is household electricity. In this chapter, we are going to learn about how electricity is supplied to our home, how it is measured, and about parallel series connections, about fuse, MCB, etc. So let us start with what is potential difference. So a cell is having potential difference between its electrodes, that is anode and cathode. Potential difference can be defined as the work done in moving a unit charge from one electrode to another electrode. And it is measured in the unit volt after the name of the scientist Alessandro Volta. And the current can be defined as the rate of flow of charges in a unit time. It is measured in ampere after the name of the scientist, Ampere. Now, suppose we have a circuit which is given here, see here. We have a current I which is flowing through a conductor of resistance R for a time t when a source of potential difference V is connected across its end. We are here to find the amount of electrical energy supplied by the source. So by different definition, we know that potential difference is the work done in moving a unit charge. So suppose we need to move a Q amount of charge or a charge Q through a potential difference V. We can say that the work done is W is equal to Q into V, where Q is a charge and V is a potential difference. But we already know that current is charge upon time by the definition. So we can say that W will be equal to VIT. We have the formula W, that is work done, is equal to charge into potential difference. Now in the place of Q, if we put I into T, so we get the formula work done is equal to VI into T. Whereas V is a potential difference, I is a current, and T is a time. Already got the formula that W is equal to VIT. That is, it gives the electrical energy W supplied by the source in providing the current I for time t in the conductor under the potential difference V. Now, based on this, we can calculate the power. Power is the rate of doing work. So that is P is equal to W by T. And if we substitute the value of W, that is VIT, into this formula, we get the formula P is equal to V into I. That is, power is equal to potential difference in volt into current in ampere. That is, 1 watt is equal to 1 volt into 1 ampere. Now next, let us see how the transmission of power from the power generating station is done to the consumer. So we will see here how it is transmitted. First, it is generated, power is generated at power generating station, and it is generated around at 11 kilovolt. After generating the power, it is then raised to 132 kilovolt, from 11 kilovolt to 132 kilovolt, and then it is transmitted to the grid substation. At the grid substation, its voltage is further reduced from 132 kilovolt to 33 kilovolt before sending to main substation. And there the voltage is further reduced to 11 kilovolt. And finally, it is sent. Power is sent to the city substation where the voltage is reduced to 220 volt so as to supply to the consumer. So at your home or to the consumer, it is supplied at 220 volt. Again, why this power is raised and decreased? The power is raised so that there will be less loss of power during the transmission, since the generating station is located far away. And thus, finally, it goes to the consumer at 220 volt. Okay. Next, we have supply of power to a house. The electric supply to our house is from the city substation. It can be either through the cable or through the overhead cables or through the underground. Wire is basically of three types. The cable has three wires, that is live wire. Number one is live wire. Number two is neutral wire, and number three is earth wire. Now, live wire is also called the phase wire, and it is at 220 volt and it carries current from the source to the distribution board. So live wire is the one which is carrying the current. Next, you have neutral. Neutral wire is for the return path of the current. And the earth wire, it passes the current to the earth. Color coding of all the three wires. All the three wires are having different type of colors. That is, the live wire is red or brown in color. Neutral wire is black or light blue. And whereas earth wire is green or yellow. The colors allow us to identify the purpose of each wire. Now, commercial unit of the electrical energy which we are consuming, or electrical energy, is measured in BOT or kWh, that is kilowatt hour. 1 kilowatt hour is defined as the amount of energy consumed when an electrical appliance of power 1 kilowatt is used for 1 hour. The energy consumed in our houses or factories is measured in this kilowatt hour. Now, we know that power is equal to energy divided by time. So, energy is power into time. So, if we want to calculate 1 kilowatt hour, 1 kilowatt hour means what? It is 1 kilowatt into 1 hour. And 1 kilowatt means 1000 watt. And 1 hour means 3600. That is 60 into 60. 3600 seconds. So when you calculate, we can say that 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. That is, we are calculating energy. So energy here, when we say 1 kilowatt hour, it means 3.6 into 10 to the power 6 joule. Next, we have electrical meter. Electric meter, we all have seen, it is there in our house, and it is also known as kWh meter. That is kilowatt hour meter, because it measures the amount of electric energy consumed by the consumer in this unit, kWh, kilowatt hour. And we are paying the electricity bill on the basis of this unit. And here in the figure, you can see there is a meter, and the main part of this meter is an armature. This armature which is connected to the main line. And whenever there is an electric appliance working, the current will flow through the meter and which will rotate the armature. This armature which you are seeing here will rotate. Okay. Now this is connected to 5 dials. This armature is connected to the 5 dials here, as you can see. And this 5 dials from right to left will measure your energy in units, tens, hundreds, thousands, 10,000 respectively. In this figure, you can see it shows a meter reading 49180 kilowatt hour from this meter. And nowadays, this old meter is replaced by new electronic digital meters. And that is shown here, electronic digital meters. Okay. Next, we have electric fuse. Fuse is a device which is used to limit the current in a circuit. It actually safeguards our appliances, or it protects our appliances from being damaged because of high voltage, or that is voltage fluctuations, or short circuiting. You can see this fuse in this given diagram. It consists of a wire. See, this is a fuse wire, which you can see in blue color. This is a fuse wire which is stretched between the two terminals T1 and T2. And it is put into a porcelain holder. So this is a fuse wire, blue color, which you are seeing here, and it is connected to the terminals T1 and T2. Now, how does it work? So during short circuit, okay, you might have heard this word short circuit. So first of all, what is short circuit? So if the insulation on the wire of the cable used in wiring breaks, then the live wire may come in contact with a neutral wire and this results in short circuit. And at this time, maximum current will pass through the wire. And this may lead to burning of the wire because of excessive heat. In the same way, during voltage fluctuation also, there are chances that a lot of current may flow through the circuit and may cause damage to the wire, burning of the wire. And to prevent this damage, fuse is connected to the live wire. And when there is a short circuit, the fuse wire will get heated up and it will melt. And when it melts, a gap is produced. See, you can see this is a fuse wire. If it melts, a gap is produced, and so the current cannot pass. As a result of the gap in the live wire, the circuit will become incomplete and the current will not pass. So our appliances will be safeguarded from this short circuit or voltage fluctuation. So the purpose of fuse is to safeguard our appliances. Now we have some of the characteristics of fuse. Very important. First of all, it is a wire of short or low melting point and it is made up of an alloy of lead and tin. It's a combination of lead and tin. Then this wire is always connected in series with the live wire. And compared to the copper wire, its temperature rises much faster and which may lead to the melting and breaking of the circuit. The thickness of the fuse wire depends on the current rating of it. That is, higher the rating, thicker is the wire. Now, a note is given here. You have to very clearly understand that an ordinary copper wire cannot be used instead of a fuse wire. Fuse wire is different than the copper wire. And the reason is because the melting point is much high. So we should take care that an ordinary wire is not used in place of fuse wire. Now next we have MCB, miniature circuit breaker. So MCB is a better version of fuse. In MCB, a switch is there, as you can see in this diagram. In MCB, you can see there is an automatic switch. And whenever the current flows in excess, this switch will automatically fall down, breaking your circuit. And so your circuit will be saved from the excess current. And once the fault is rectified, you can just put it on, send it back on, and then it will work as usual. So we can see that MCB is a better version of fuse. Both does the same work, that is safeguarding your electric circuit from excess of current. So this is MCB, miniature circuit breaker. Now next we are going to see the difference between series and parallel connection. Series and parallel. See, here you can see how the bulbs are connected. They all are connected one after the another, two bulbs. Only one path is there. The current is passing through the one path. So this is a series connection. Whereas here you can see two or more paths. Current is split into two paths and passes through each branch at the same time. And very clearly you can understand that here both of them are dependent because they are in the same path, or the current passes through the same path, only one path. Whereas in this particular diagram, you can see that the current is passing in through a branch. They are branched. So they are independent. So series and parallel, when we say in series, one after the another in a single path, the bulbs are connected, and whereas in parallel you have two different bulbs where the current is split to pass through different branches at the same time, and they both are independent. Now in such kind of series connection, the problem is if one bulb is not working or if it is damaged, the circuit will become incomplete and the other bulb will also not light up. Whereas in this parallel connection, even if one bulb is not working, it will not affect the other one. It will automatically work. Why? Because here they have different path. So even if one doesn't work, the other will work. So from this, we can conclude that series connection is not suitable for our household appliances. At home, every appliance is having different switch. When one bulb is working, it is not required that the fan may also work. All are independent. So we can say that parallel connection or parallel circuit is there at our home in various appliances. And some of the uses is this kind of parallel circuits are used in our household circuits. It can also be used in twinkling stars, where one is glowing, another one is not glowing. For that purpose also we can use parallel connection. So remember, at home we have parallel connection, and the reason is all the appliances can work independently. Every appliance is having different switch and they are independently working. Now next we will see that power rating of appliances. What is the power rating? So we already have the formula that P is equal to V into I. Or I can say that the safe limit of current for an appliance, that is I, is equal to P upon V. So if I have a bulb which is rated at 100 watt and it is lighted at 220 volt, we know that to our home its a supply is at 220 volt. So if I have a bulb which is rated 100 watt and it is lighted at 220 volt, then the safe limit of current for that particular appliance can be calculated by this 100 divided by 220. That is by this formula, I is equal to P by V, which comes to be 0.45 ampere. So this is the safe limit for this particular appliance. So that is power rating of appliance. Next we have earthing of the appliance. Equipments or appliances like refrigerators, ovens, the outer body of such appliances are always connected to the earth wire. The reason is sometimes due to breaking of insulation of wire, live wire may come in contact with the body of the appliance. And because of this, we may get a fatal shock through the appliance when it is touched. So to prevent this, we have a concept of earthing. That is, if the appliance is earthed, the current will pass to the earth and not transfer to our body, and we may remain protected from the electric shock. The metallic outer body of every appliance is earthed, that is, it is connected to the earth wire. And the reason is to safeguard against this shock, which may happen because of the breaking of insulation of wire. So it's very important to earth the appliances. Okay. Next, we have hazards of electricity. Already you know that what all dangers are there of electricity. Some of them are mentioned here. That is, when a large number of gadgets are connected in a circuit, so there are chances of overloading. That is, when large amount of current flow through the wires, there are chances that there is overloading. Circuit gets overloaded, excess of current. And the other one is sometimes live wire may come in contact with neutral wire, and which may lead to short circuiting. And again, at this time, will be a lot of current in the system, in the circuit. And finally, if a person comes in contact with a live wire, he may get a shock. And if the shock is huge, it may also cause death of the person. So these are some of the hazards of electricity. Last, we will see precautions. What all precautions can be taken while using electricity? So some of this we already know, they are general. Some other points are also mentioned, like for example, do not touch with wet hands. This you already know. Some other point is this: the ordinary copper wire should not be used. This is again repeated, that the ordinary copper wire should not be used as a fuse wire, because the melting point of copper is this much degree Celsius, 1080 degrees Celsius. Whereas the fuse wire, its melting point is 200. So it will melt quickly compared to the copper. And that is what we need in a fuse. So we have to take care that ordinary wire should not be used in the fuse wire. The next is proper insulation. Wire, when you are using, check that if it is having proper insulation or not. We should also make sure that MCB or fuse should be connected to the live wire. It should be connected to the live wire. Some of the general reasons are mentioned here, that we should not touch with wet hands. All the connecting wires, plug sockets, etc. should be tightly joined. We should ensure that the appliances are properly earthed, and we should not try to repair any appliance when it is in use. When the connection is on, when the electricity is passing, we should not repair any appliance. And lastly, to switch off the gadgets like TV, geyser, etc., it's better to take out the plug from the socket instead of just using the remote and switching it on. So children, we have learned many things from this chapter. I hope it helped you to revise the topic. Thank you.